These are the 4.3 notes for pre-calc. We are going to talk about imaginary numbers today. So the first question is, what are imaginary numbers? In math, we know that we can't square root negatives until now. We did this a little bit back in Algebra 2. So up until now, if you had taken the square root of -4, you would have gotten no answer. Does not exist, error message in the calculator. But what we're doing is we're going to go ahead and say that it is an imaginary number, meaning it's not a real number. And the answer would be plus and minus 2i. So you would just take the square root of the 4, 2, and because it's a negative, you would just put an I on there. I is actually the square root of -1. All right, so another example, you could take the square root of -25, and you would get plus and minus 5i. The next thing I want to talk about is a complex number. Complex number is when you have a real number and an imaginary number together. So a real number is the ones we're used to, like 7, and then an imaginary number would be an I. So if you had 7 plus 3i, that together would be a complex number. You couldn't add the two. I's act just like x's, so you would just kind of leave it as 7 plus 3i. Or maybe you had -11 minus 2i. Those are examples of complex numbers. Next question, how do I multiply imaginary numbers? So you multiply i's just like you multiply x's. So I times I will get you I squared. So 2i times 2i would get you 4i squared. And I squared, because I is equal to the square root of -1, I squared is just equal to -1. So if you come up here and you square both of those things, the square root and the square would cancel out, and you would have I squared equals -1. So anytime you see an I squared, you can replace it with the real number of -1. So this would become 4 times -1, which would become -4. Example 2, I multiply those together to get -25i squared. I squared is -1, so I can replace that with -1. Then you can multiply those two together to get positive 25. Example 3, even if you don't have any real numbers there, you can count this as like a -1i and a positive 1i. So you could even rewrite it like this if you wanted to. Either way, that gets you -1i squared. I squared is -1. So now you have -1 times -1, which gets you positive 1. I am writing out all the steps for these up here, but if you can go straight from the I squared to multiplying it by -1, you don't have to show all the steps. The next part here we're going to have to do is foiling. 2 times -3, -6. 2 times 2i, 4i. 5i times -3, -15i. 5i times 2i, positive 10i squared. The first thing I want to do before I keep moving forward is to deal with this I squared at the end. So I'm just going to take this little piece and replace this with a -1. Then I'm going to multiply it out, so that way I get -10. I'm just going to bring everything else down. So that positive 10i squared turned to -10. Then you can combine your like terms. Your real numbers, -6 and -10, make -16. And your imaginary numbers together make -11i. Make sure you don't square that when you're adding the i's. Only square the i's when you're multiplying. Take a moment and try example 5. Make sure you can FOIL it. you should have something that looks like that. Your next step is to replace the I squared with a negative 1. So you can cancel that out if you want and put a negative 1 right there. I'm going to rewrite the entire thing. Negative 9 times negative 1 is positive 9. Combine the real numbers 16 and 9 to make 25. And when I combine the negative 12i with the positive 12i, they actually cancel out. So my final answer is just a real number. And that happens every time you have kind of this pair. When you have the opposite sign in the middle, the imaginary part of that ends up canceling out every time. That type of pair of numbers is what we call a conjugate, which leads us into the next part. So what is a conjugate? It's when you change the sign of the imaginary number. So notice this 4 plus 3i and 4 minus 3i. That's what we call a conjugate. You want to keep the sign of the real number the same. So change the sign of the imaginary, keep the sign of the real. And these zeros, these x-intercepts that we've been talking about, these imaginary and complex, they come in pairs. So every time you have a 4 plus 3i as an answer, you're also going to have a 4 minus 3i. And that's because up here of this plus and minus sign. So you'll always have the positive version and the negative version. Those are called conjugates. So why are conjugates useful? It helps me find another one of my zeros. And when I say zeros, I'm talking about the zeros from your 4.1 notes, the x-intercepts that we graphed on your 4.2 notes. So if 4i is a 0, then the opposite sign, negative 4i, is also a 0. And we're always trying to look for our zeros because our zeros are the answers. 7 plus 3i is a 0, then 7 minus 3i is also a 0. Again, you change the sign of the imaginary, keep the sign of the real number the same. Negative I and positive I. Negative 1 minus 2i, keep the real number the same, change the imaginary part. Negative 1 plus 2i. Now, what are we actually going to do with those? Let's flip it over to the back side. What we're going to do is we're going to use these to write polynomial functions. The thing about polynomial functions, when we write it, it's going to end up being in factored form. So just like before, we're just going to have a bunch of parentheses. The thing about the factored form is you're not allowed to leave an I in the problem with your x's. So there's a shortcut that will help us write these. X squared minus the sum of x plus the product. And I'll explain what that means in just a moment. Make sure you have that. Very important. All right. Example number 6, write a polynomial of degree 3. So they're telling me how big it is. There'll be a total of 3 x's represented in this problem. And it also tells me how many zeros there are going to be. So this tells me how many zeros. And by zeros, remember, we mean answers. We mean x-intercepts. So they tell me 2 of them. Here's one. Here's another. Because it's a degree 3, I know there's going to be a third. We just learned that the imaginary numbers come in pairs. So if there's a positive 2i, there automatically is a negative 2i. Now that you know all 3, we can go ahead and write this into function form. So we'll have f of x equals, and then we're going to take each of our zeros and plug them in. So we're going to start with this x minus 3. Remember, we always put it in as an opposite sign, x plus 3. But then this I part, well, I don't want to put these in as i's. We're not allowed to write i's with x's. So what I'm going to do is I'm going to use this kind of shortcut over here, this x squared minus some x plus product. So what I'm going to do is come off to the side here, and I'm going to find the sum. And by the sum, I just mean adding the 2i and the negative 2i together. That's pretty simple. Those just cancel out and get me 0. Now I got to work on the product. The product is when I multiply these two together. So I'm going to go ahead and put them in parentheses. We practice multiplying on the front side. Negative 4i squared. Remember, I squared turns to negative 1. Then I have negative 4 times negative 1 is positive 4. So the 0 is going to go in for the sum, and the 4 will go in for the product. So I'm going to write this x squared part right here. X squared minus whatever answer I got for the sum, 0. Then put the x there. So don't forget about this x right there. Plus whatever answer I got for the product, which would be 4. Now, most of the time when people write it, they don't write that 0x because it's a 0. So you'll probably see it more looking like this, x plus 3 and x squared plus 4 for your final answer. And this should kind of make sense to you based on what we've been doing the last couple of days. This right there, if you set that equal to 0 and solved it out, negative 4, you would take the square root of it. And it doesn't get you any real zeros, but it does give you some imaginaries, plus and minus 2i, which kind of checks out right there. This part is not necessary at the end. It's just a good way to make sure that you've done it correctly. I'll go ahead and erase that. Save us a little bit of room for later. All right, let's try example number 7. Write a polynomial function of degree 4. Remember, this tells me how many zeros there are going to be. The zeros, they give me some of them, negative 3, positive 5, negative 3i, he's missing his conjugate pair, opposite sign of the imaginary. So these real numbers, the negative 3 and the positive 5, they don't come in pairs. Only the imaginary parts come in pairs. F of x equals. The negative 3, I can just go ahead and write as the opposite sign. The positive 5, I can write as the opposite sign. So those two pieces of the real numbers are pretty easy. For the imaginaries, you're going to come off to the side. And I've got some space over here. I'll just do my work over here. You're going to do negative 3i plus 3i. You're going to do negative 3i times 3i. These add together to make 0 again. And no, it doesn't always give me 0. We're going to see that on example number 8. Multiply these together. Negative 9i squared. I squared becomes negative 1. And that becomes positive 9. So then I write it back into the formula. So 0 is my sum, so I write x squared minus 0x plus 9. And then you want to take off that 0. If you didn't want to write it in the first place, that's okay. But 0x is just, can be ignored. And that's a good final answer. Notice your degree 4 is represented. You have an x here, and then 2 x's right there. Okay, so for example number 8, we're going to amp this up a little bit. I've got a degree 3, so I've got zeros of 1, 2 minus 5i, which means my other one is going to be 2 plus 5i. Change the sign of the imaginary number. Leave the sign of the real number alone. You can start with the x minus 1. And then this next part, remember, you're not supposed to move on with the i's. You can't put the i's directly into the parentheses. So what we're going to do is just come off to the side here, use our shortcut, this x squared minus sum x plus product. So we're just going to find both of those. I'm going to do 2 minus 5i and 2 plus 5i. And I'm just going to kind of add that like we used to do in elementary school. So normally, on the last two problems, I've gotten an answer of 0 for the sum. Here, the imaginary parts cancel out, but I still have these two positive 2's. So this time it's going to give me a sum of 4. And the product this time is actually going to look like this, 2 minus 5i and 2 plus 5i, which means we're going to end up foiling that. So just like we did on example 4 and 5 on the front side, we're going to take this and slowly FOIL it all the way out. 2 times 2 is 4. 2 times 5i, 10i. Negative 5i times 2, negative 10i. Negative 5i times 5i, negative 25i squared. When you FOIL the conjugates, these two middle terms will always cancel out. Always, always, always cancel out. I squared I know is negative 1, so now I have 25 times negative 1. Right? This I squared can just be replaced with negative 1. Multiply those. And I get a product answer of 29. So then I'm going to put my 4 and my 29 back into this equation up here, this sum plus product. So I write x squared. Now be careful here because notice the sign is a minus. So write minus 4x. I know your 4 was a positive, but the formula has a minus sign in it. And then plus 29. It's a decent amount of work to find that product, but I know you guys can do it. Just work very carefully. All right, let's try example number 9, our last one. Notice again your degree 3, which means you have negative 2, 3 plus 2i, and this one always comes with a pair, 3 minus 2i. I've got all three of them taken care of. And you can either start off to the side with your sum and product, or maybe you want to start your equation right here by putting your negative 2 in as a positive 2. Okay. Then come off to the side. You're going to find the sum. 3 plus 2i and 3 minus 2i. Add those together. And then we're going to find the product. FOIL 3 plus 2i and 3 minus 2i. Take a moment here and see how far you can get in this problem. It's good to test yourself to make sure you understand it, and then you can ask any questions that you have during class. But if you just copy down my work, it's going to seem super easy. So go ahead and take a second and try this problem. You should have gotten a sum of 6 and a product of 13. So when you write it in here, remember it's x squared minus sum x plus product. There we go.